All right, so today we're going to take a look at the next lesson, lesson 1.6. Before we get to that lesson, take a look at the problem of the day and read the problem, complete the work, and describe and correct the error in writing the equation there. Make sure you pause the video, and when you're ready to move on, you could press play again. All right, so 1.6 is called solve linear inequalities. And a linear inequality is one variable can be rewritten, results in a true statement where a and b are real numbers and a does not equal 0. So here's how we can write linear inequalities. There's 4 types. Ax plus b is less than 0. Ax plus b is greater than 0. Ax plus b is less than or equal to 0. And ax plus b is greater than or equal to 0. All right, and what is a solution? A solution is an inequality in one variable is a value that, when substituted for the variable, results in a true statement. Graph consists of all the points on a number line that represent solutions of an inequality. So inequality, what's happening now? Instead of seeing an equation with an equal sign, we have an inequality. All right, you pretty much solve them the same way. All right, now before we get to actually solving them, first thing is we're going to graph some basic inequalities. All right, so normally if I graphed a point on a number line, it's a solid circle, that's a dot. Inequalities, we have 2 different things going on. We have either an open or a closed circle, and also we shade part of the number line. So let's take a look here. Example 1a, graph x greater than -3. All right, so let's locate -3 on the number line. It's not or equal to, it's just greater than. So we're going to have an open circle on -3. Now, greater than means it gets bigger. So we're going to shade to the right. A little shortcut, as long as the x is on the left-hand side, is the inequality points sort of in the direction. So do you see how the inequality points to the right? It's another way to take a look at it as well. All right, let's take a look at graph x less than or equal to 0. This time it's or equal to. So when we find 0, we're going to color in a closed circle. And less than means the numbers keep getting smaller. So we're going to shade to the left. Okay. Now, the next one, those are pretty easy, right? And hopefully you remember some basics on graphing. Let's now take a look at if I gave you a compound inequality. All right, so first we're going to take a look at the definition of it. Compound inequality consists of 2 simple inequalities joined by and or. Now, if it's and, we'll take a look at letter A. A is and, B is or. Or actually has to have the words or. All right, so let's look at example 2. A graph. Now, I'm going to read this out loud, so follow along with how I read. It's different because I start with the middle. So I always start with x, I read to the left, and then I go back to the right. So watch how I read this, and listen along as you look at the problem. I read letter A as x greater than or equal to -2 and less than or equal to 3. All right, one more time, x greater than or equal to -2 and less than or equal to 3. So how do I graph these? All right, so it's greater than or equal to -2. So here's -2, and we're going to do a solid circle because of the less than, or because of the or equal to line below it. And it's greater than or equal to, so I'm not going to shade all the way yet, but I'm going to start to shade to the right. And then the other part is it's less than or equal to 3. So 3 is also closed circle here. And less than or equal to means I start going to the left. The numbers get smaller. What you're going to see with an and compound inequality is it's usually inclusive of a whole bunch of numbers. I think of the -2 and the 3 as the endpoints. So here's our graph for an and we'll have you where you shade in the center. Okay, any questions? Just pause the video or ask me in class. All right, now what about the or? How is that different? Well, or is like I just gave you 2 separate inequalities and I told you graph them all on the same line. All right. So x less than -1. Here's -1. It's an open circle. Less than, my numbers go to the left. They keep getting smaller. And the other part is or x greater than or equal to 1. So let's find 1. It's or equal to, so color it in. And it goes to the right because it's greater, it gets bigger. So let's assess and take a look at what happened here. In or inequality, you'll notice that the middle is not shaded in. It's pointing to the left and right. It goes down forever in both directions, but the middle is not filled in. And like in letter A, it's, I think of the numbers as like a range, as an endpoint. That's all the numbers in the middle. Okay. So now we're going to get a chance to solve and graph coming up. So let's read the definitions here. Equivalent inequalities. Inequalities that have the same solutions as their original inequalities. When we solve for an inequality, we treat with the same rules as an equation. The only difference, when we divide or multiply by a negative number, we reverse the inequality sign. So here's our example. Negative 3x plus 2 greater than 14. Take a look at the work that I did. All right, when we treat it as if it's an equal sign here, how we solve. But in the end, if you notice, I divided both sides by negative 3. The only difference is when you divide or multiply by a negative, the inequality switches. So just be mindful of that. Now let's take a look at example 3. Solve the inequality, then graph the solution. All right, so we are going to take a look at letter A first. And actually, we might type this here, so hold on. All right, so here's what I'm going to do. I'll move my work up. Okay, so here's our problem. 4x plus 3 less than or equal to 6x minus 5. So we're going back to simple inequality. Let's move all the x's to the left. I'm going to write 4x minus 6x. Keep the less than or equal to. And then on the right I have what? Negative 5 minus 3. Okay? From there, let's simplify. 4x minus 6x is negative 2x less than or equal to negative 8. And be careful, we're going to divide both sides by negative 2. All right? When we divide by negative 2, watch what happens here. Obviously, negative 2 divided by negative 2 is negative 2x divided by negative 2 is just x. Don't forget, because it's divided by a negative, that the inequality switches. All right? And negative 8 divided by negative 2 is 4. All right? And that's our answer. X greater than or equal to 4. All right, how do we graph that? Let's find 4 on my number line. Or equal to means it's solid. Greater than or equal to, draw your arrow to the right. Numbers increase. All right? Now, next one. Let's take a look at this inequality. And if you want to, really what I would say first is, I'm giving you two of the same type. Pause the video and try B first. See what you can do without me talking here. All right? All right, so let's get the x's, transpose them all to the left. So I get 5x minus 7x. We have greater than or equal to negative 4 minus 2. Let's put my negative there. All right. And simplify, get negative 2, x, negative 2x, greater than or equal to negative 6. And remember, we're going to divide both sides by negative 2. Negative 2x divided by negative 2 is just an x. And don't forget again, the inequality switches because it's divided by a negative, just like letter A, just like the last concept I wrote. Negative 6 divided by negative 2 is a positive 3. So there's our answer, x less than or equal to 3. So let's find this one here. All right, so find 3, close circle. Less than or equal to means I shade, numbers decrease, shade all the way going to the left. Okay? All right, that brings us to the close of the first part of lesson 1.6. So here's your homework problem of the day. Number 2, graph the inequality. You could do that on the paper, draw a number line, or in your notebook. 3, solve the inequality, then graph the solution.